Well, hi everyone, and thanks again for coming back. What I'd like to do now is talk about the design of the more typical case control study, the one that existed more often in the past. It's called the density type case control study. And to describe it, let's imagine the example I've talked about a few times. Let's suppose you want to know whether oral contraceptive use might increase a woman's risk of developing breast cancer. And what you're going to do is a case control study. You're going to go to your local hospital. You're going to enroll women who are diagnosed with breast cancer to be the cases in your case control study. And now what you have to do is select your controls. And here's the problem. Unlike Dr. Willett, where he had 111 individuals who developed cancer out of the hypertension and detection follow-up programs, that experimental study, Dr. Willett knew the closed cohort that gave rise to those 111 cancer cases in that study he did. But now imagine doing your study at your local institution. You have women diagnosed with breast cancer, and you're enrolling them as cases, and the problem is, what's the source population? What's the cohort study that existed in the past, that if you had created it and followed it forwards as a cohort study in the past, and looked at how many people developed breast cancer out of that cohort study, those outcomes of breast cancer would have been the same women who now you're enrolling in your study as your case control study as your cases. Well, we don't have a freezer full of bloods. We don't have the names and addresses of everybody who was in that closed cohort that Dr. Willett used. Now we have a different cohort, people who were living in the past, being followed in the past. Had they developed breast cancer, they would have been in your hospital, meaning they would have come to your hospital and been diagnosed as breast cancer, and they now would be cases in your case control study. Well, what is that source population? What's that cohort study? Well, probably it was open in a dynamic population, people moving in and moving out. Probably it was a population that was somehow linked to that hospital, people who would seek care and have disease diagnosed at that hospital. So the easy part is your cases. You know who those women are. They were women who were diagnosed at a particular hospital. The problem is your controls. What do you want them to do? You want them to reflect the source population that gave rise to those cases. You want them to reflect that open cohort study that probably existed in the past, that if it had existed and been followed in the past would have identified those cases in your case control studies as the outcomes from that cohort study. The cohort study was probably open and would probably reflect what we refer to as the catchment area for a hospital. The area, the population that that hospital serves. And that is, again, probably a very dynamic, very open, very much not well-defined population, but that's what we want our controls to reflect. That's the basis for what we call a density case control study. Remember, what we're talking about is an open cohort study that existed in the past. In an open cohort study, what do we measure? We measure incidence rates. And as measures of association, we measure incidence rate ratios. That's what we're going to be estimating from these density type case control studies. The rate ratio we would have seen in that open cohort if we had created it and followed it over time, and it had given to us the outcomes that are the cases in our case control study. Well, why do we call it density type case control study? Well, in classical epidemiology, in the history of epidemiology, the notion of incidence rates has been called by different terms. The biostatisticians refer to those as hazard rates. Marcello might be referring to that when he talks about survival analysis. A group of epidemiologists would also, in the past, refer to those as incidence density instead of incidence rates. And that's why the word density is being used, because we're describing a case control study that's linked to an open cohort study that would have given us incidence rates or incidence densities. The cases, the people we start with, are in our minds the outcomes that would have happened, that would have been observed from that open cohort study if it had been followed over time and if incidence rates were being measured. The challenge is measuring the controls. So here's our open cohort. In our minds, if we actually had the ability to recreate it, we would have seen a population that's probably dynamic, people moving in and out of some geographical region that's being served by this local hospital. And what we observe is follow-up time, different periods of follow-up time for different individuals. And out of that follow-up time, some people developed breast cancer, went to that hospital and had it diagnosed, and are now the cases in your case control study. That's the case part of our case control study. Who are going to be our controls? Our controls are selected to reflect how much of that person time was contributed by people using oral contraceptives and how much of that person time was being contributed by people not using oral contraceptives. We can ask our cases individually, did you or did you not use oral contraceptives in the past, to measure their exposure and their exposure odds. We want to know how much person time in that open cohort was made up of person time from people using oral contraceptives and from person time from women not using oral contraceptives. So what we're going to do is we're going to select controls out of those person times. We're going to ask those controls, did you or did you not use oral contraceptives? So in our density type case control study, our X's are going to be the people who developed the disease, our cases. Our O's are going to be the people who were being selected as controls to hopefully reflect the exposure distribution and the person time that existed in that open cohort study. So what are we going to have for data in a density type case control study? Hopefully data that's going to reflect the information we could have gleaned from the open cohort. In the open cohort, we would have been measuring person time for individuals. We've been classifying person time as being from oral contraceptive use or non-oral contraceptive use. We observe how much person time came from the exposed people and from the non-exposed people, those using or not using oral contraceptives. We were able to observe how many cases of breast cancer observed in each of those groups. We could measure from an open cohort study, we could measure rate ratios. We could measure the incidence rate of breast cancer among the people who are using oral contraceptives. That would be A divided by K1 person years. We can measure the incidence rate of developing breast cancer among the women not using oral contraceptives, C over K0, and we would measure the incidence rate ratio. Remember, mathematically, I said that incidence rate ratio is numerically the same as first, look at everybody who developed the disease, breast cancer, and measure the odds of exposure among those people, capital A divided by capital C, and divide it by the ratio of how much person time was contributed by exposed people to how much person time was contributed by non-exposed people. And that's what the controls are trying to give you, an estimate of the relative sizes of the person time contributed by exposed people to the person time contributed by non-exposed people. If it does that, your exposure odds ratio from your case control study is going to be able to estimate your rate ratio. So what your data would look like is when you select your controls, you want your controls to provide an estimate of the size of the person time, exposed person time to non-exposed person time. So this is what data would look like from a typical density type case control study. You enroll a series of cases, maybe from your hospital, people with breast cancer. You ask them in the past, were you an oral contraceptive user? And A of them claim they were, or were you a non-user and C of them claim they weren't? You're estimating the odds of exposure among everybody who would have become an outcome in that underlying open cohort study. You'd be selecting some controls, hopefully to reflect the person time that was being contributed in that open cohort study. You'd ask your controls, were you an oral contraceptive user or a non-user? B of them would say yes, D of them would say no. Your exposure odds among your controls, B over D, estimates hopefully the size of the amount of person time in that open cohort that was contributed by oral contraceptive users, K sub 1, over the size, the amount of person time contributed by non-oral contraceptive users, K0. So when you measure your exposure odds ratio in that data set, hopefully you're coming up with an estimate of what the incidence rate ratio would have been, the rate ratio in that underlying cohort. That's the basis for a density type case control study. Now what I'd like to do next is to show you an example of a density type case control study. But before we do that, let me just make a few last comments about the selection of controls, especially when you're doing the density type case control study. How do you find these controls? Well, the way I think you find these controls is first by finding your cases. That's the easy part of a case control study. You enroll cases, and in your mind, you're trying to imagine what's the cohort study, what's the source population that gave rise to those cases. It could be an open cohort study, it could be a closed cohort study. I want to try to distinguish between two types of cases that can impact your controls. Remember, what we want our controls to do is to reflect the population at risk. Suppose our cases are not selected from one single hospital, but from a large population. So let's suppose our cases that we select for our case control study represent a population. You went to all the hospitals in your region, selected all the women who were diagnosed with breast cancer. You're getting hopefully a representative of all the cases in some geographical region. Well, if that's your definition of controls, your population at risk, the source for your controls, should reflect that geographical region. You're talking about selecting population controls. You'd essentially like to take a census, a random sample of a complete census of a geographical area. Well, that's somewhat hard to do. What has been done recently is people have tried to come up with ways to try to take representative samples from a general population by using something called random digit dialing. We have a machine that randomly dials phone numbers, randomly selects people in that way to be answering your questions about their, for example, previous oral contraceptive use. And you probably have, if you live in this country, been exposed to these machines where your phone will just ring and there'll be a person after a certain period of time waiting on the end asking you some questions. The problem is what it's selecting at random is not people, but selecting at random phone numbers. So if you happen to have two phones in your home, you are twice as likely to be selected in this random digit dialing scheme as a person who has one phone. If you have no phones, you have no chance of being selected as a control in this study. If you don't answer your phone, as I don't do at dinner time, you have no chance of being selected. So there's no guarantee that the people who are contacted through random digit dialing are truly a random representation of some geographical population. But that's the motivation behind selecting controls that are population-based when your cases are population-based. On the other hand, if your cases come from a single hospital, so for example, you go to your neighbor hospital and all your cases of breast cancer are enrolled in your study as cases for your case control study, you probably want to select your controls from that same hospital somehow. Because remember, what you want your controls to do is reflect the source population from which the cases came. If the cases only come from one hospital, you'd like to select controls who are at risk of going to that hospital if they develop disease and being selected as cases from your case control study. So typically, when you're selecting hospital-based controls from the same hospital that your cases came from, what you're trying to estimate is the exposure history in the catchment area of that hospital, the geographical region that that hospital serves. But a hospital's catchment area is not just geographically defined. You might be working with a hospital that's a major referral center that receives cases from not just the surrounding neighborhoods, but the surrounding states. And therefore, the catchment area is not just the surrounding neighborhoods, but some larger geographical area. The catchment area might be defined by socioeconomic status. These might be a hospital that's serving a low-income population. People from no matter where they live come to this hospital because that's the only place they can get adequate care based on the resources that they have. Or it might be defined by an insurance policy. If you have a certain insurance policy with a certain company, you have to go to this hospital to receive your care. In all cases, what you're trying to do in your minds is to identify the cohort study that existed in the past that would have led to outcomes which are your cases. And if your cases come from one hospital, you want your source population to be linked to that one hospital. And the problem, it's often poorly defined. You don't have a clear idea in your mind of what this population at risk would be. So how do you resolve that? Well, you make a couple of assumptions. First of all, you assume that people who come to this hospital because they're diagnosed with breast cancer would have come to that same hospital if they had other diagnoses. You assume that you can choose other people in the hospitals to reflect the catchment area. Even though you can't clearly define the catchment area in your mind, you can choose other people with other diagnoses in the hospital as coming from that same catchment area. So your controls are typically people with other diagnoses in the same hospital. what you're assuming is that those people share the same catchment area. If your cases are people with cases of breast cancer and your controls are women with broken bones, you're assuming the diagnosis of broken bones among women at this hospital come from the same catchment area as your cases of breast cancer came from. Now, if that's true, which group of people in your hospital do you choose as your controls? Well, the trick is you want your controls to reflect how common the exposure is in that population at risk, in that catchment area, in that source population. You want essentially your controls to be as close as possible, a representative sample of that catchment area, which means what you don't want are controls for whom their diagnosis might be caused or prevented by your exposure of interest. So for example, if your cases are cases of breast cancer, and you choose as your controls women diagnosed at that same hospital with the condition of venous thrombosis, which is linked to oral contraceptive use, and ask those controls how often did they use oral contraceptives in the past, their answers, their exposure odds, are probably different than what existed in the general catchment area in that source population, because your selected controls are people with the disease caused by the exposure. So you want your controls to be selected in such a way that the diagnosis they have is not related to the exposure of interest. And typically what that means is you enroll more than one control group, because your worst nightmare is you select your cases of people with breast cancer, you select your controls with women with another diagnosis, and then sometime a year later someone publishes a paper that shows that oral contraceptive use could cause that other diagnosis that you use to define your controls. So typically your controls are made up of different diagnoses, and as far as you know are not caused or prevented by the exposure of interest. That's the background of a hospital-based density type case control study. So the next time we come back, I want to give you an example of a hospital-based nested case control study. See you next time.